All right, let's talk about something crucial in the world of heavy-duty machinery, conveyor chains. We're going to do a deep dive into what actually makes a chain high performance. And I'll tell you right now, it's about a lot more than just a few links of metal. We're talking raw power, really smart engineering, and a promise of quality that you can literally see. So let's get into it.
But first things first, we need to frame this with a really important question. What's the actual cost when a conveyor chain is weak? Because in heavy industry, a chain isn't just some random part. It's the absolute backbone of the whole operation. And when it fails, well, the consequences are fast and they are severe.
And this is where you really see the high stakes of it all. I mean, think about these environments. Equipment is pushed to its absolute breaking point day after day. In that kind of setting, the old saying is true. You're only as strong as your weakest link. And just one failure can bring everything to a screeching, grinding halt.
That one failure creates a nasty domino effect with three huge problems. First, you've got downtime. Every single minute that line isn't moving, money is just flying out the window. Then there's inefficiency. A chain that's not up to snuff creates friction and wear, which just burns through energy and resources. And most important of all, the safety risks. A chain snapping under load isn't just an inconvenience. It's a catastrophic failure that puts people in real danger.
So what's the answer? How do you possibly defend against that kind of failure? Well, your first and most fundamental line of defense is just raw, uncompromising strength. It's the bedrock that everything else is built on. Just take a look at this number, 70,000 pounds. That is the certified braking strength we're talking about here. To give you some perspective, that's roughly the weight of 5 full-grown elephants. A number like that puts this chain in a class of its own, among the absolute strongest on the market, built for the toughest jobs imaginable. And just so we're all on the same page, braking strength is exactly what it sounds like. It's the absolute final limit, the maximum force a chain can take before it gives up and fails. What's so critical to understand is that in heavy industry, this isn't just some spec on a sheet. It is the non-negotiable bottom line for safety and reliability. But look, brute force isn't the whole story. Not for long-term reliability, anyway. True high performance also demands really smart design, something engineered to be efficient and to cut down on wear and tear. Let's take a look at how that actually works. And a huge piece of that smart design is this, the 4-inch pitch roller. Now that might sound a little technical, but it's a fundamental game changer in how the chain handles the load it's carrying.
This slide breaks it down perfectly. With a standard chain, the load is literally dragged across the surface. Just imagine the friction, the grinding, the constant wear. But with a roller design, the whole load is sitting on these specially designed rollers, which allows it to roll. The difference between dragging and rolling is, well, it's night and day. It's the difference between constant struggle and smooth, efficient operation.
And the long-term payoffs from that are huge. When you let the load roll, you're not just cutting down on friction. You're slashing the mechanical wear on the entire system. That means the whole conveyor lasts longer, which means you're spending less on maintenance, and that leads to real savings. It's a design that literally pays for itself over time.
Okay, so you have the incredible strength, and you have the brilliant design, but how do you prove it? How do you guarantee that every single chain actually lives up to that promise? Simple. You put it through the ultimate stress test, and the proof, as they say, is in the puller. Now, this is not your average lab test. This is a full-blown, real-world simulation. First, they set the chain up on sprockets, exactly like you'd find in a trailer. Then an electric motor gets it running to mimic actual operating conditions. And then they bring the pressure. Hydraulic cylinders apply just immense outward force, creating the same extreme loads the chain will face on the job. Finally, everything gets verified, from the overall strength right down to each tiny component. So this test does way more than just confirm that 70,000-pound number. It's about checking the durability of every single roller to make sure they don't get crushed. It's about checking the integrity of the pins that hold the whole thing together, even under insane pressure. It's a top-to-bottom quality inspection that makes sure every last part meets the standard, so the entire chain is ready for the real world. This whole intense process, from the design to the testing, it all builds up to one final piece of the puzzle. This is the mark of quality that gives you that ultimate peace of mind.
And here it is. So simple. A stamped logo. Now, this isn't just some branding exercise. Think of it as a physical seal of approval. When you see this logo stamped right onto the chain, you know. You know it passed the test, you know it's made to the right standard, and you know you're getting the real deal, not some cheap, substandard knockoff. So when you put it all together, you finally see the whole picture.
This total promise of reliability, it isn't just one single thing. It's built on these 4 pillars. You've got the raw strength of 70,000 pounds, the smart design that lets loads roll instead of drag, the punishing tests that prove it can take the heat, and that stamped logo, which acts as your final, visible guarantee of quality.
You know, in the end, it really boils down to this one idea. Quality isn't a single feature. It's a promise, proven under pressure. And it really makes you think, doesn't it? In any high-stakes job, what's the real cost of a promise that's never actually been tested? Thanks for joining me on The Explainer.